Welcome to Numerical Analysis course. Today we are going to study Gaussian elimination method. It's a method to solve system of linear equations. System of linear equations where we are given three or more linear equations and we are asked to find the values of unknowns x, y and z. Suppose we are given this equation where a11, a12, a13, a21, a22, a23, a31, a32 and a33 are the coefficients of x, y and z in these three equations, and they equate to three constants alpha, beta and gamma, and we are supposed to find the values of x, y and z, the three unknowns. We have been solving these linear equations in school and college, but today we will see a repetitive method based on the approach given by the scientist Gauss, called Gaussian elimination method. It's a very simple method. For this method to implement, we have to go through 4 steps. Step number 1 is we have to create an augmented matrix first, where we take these coefficients, put them in a matrix, and this matrix is called augmented because it has one extra column that contains these alpha, beta and gamma, the constants on the right hand side. Right. With this augmented matrix, we'll apply different row operations, row reduction technique to obtain a matrix like this, a triangular matrix like this. In this particular form, it is very easy. Once we obtain this matrix, we convert this back into equations. We started with this, and then we can very easily solve, because we can solve this equation straight away to find z, because z would be gamma prime divided by a33 prime. And then we can put the value of z here, can solve for pi, and can put the values of y and z here and can straight away solve for x. These primes are different than this number. This a11 prime is different than this a11 because we have obtained it by through repetitive row operations, and we apply these row operations unless we obtain this triangular matrix, right? So this is very simple. In order to better understand the concept given by this method, or in order to better understand this method, let's solve an example. The example is we are given 3x plus 4 pi plus z is equal to 2x plus y minus z is 3, and x minus y minus z is a 1. Right. So the first step is, step number 1 is to convert it into an augmented matrix where we write the coefficients and alpha, beta and gamma as the last column. 2, 1, minus 1, 3, 1, minus 1, minus 1, 1. This is the augmented matrix. Now the next step is to convert it into a triangular matrix where we want to have this and this position. We want zeros at these three positions, and that we'll obtain through row operations. Let's see how to do that. The first operation would be through row operations. So let's implement step number 2. Right. To obtain a 0 here, let's let's obtain a 0 here first, right? And that we can obtain by implementing this operation R2. This is R2 means row 2 is replaced with 2 times R3 minus R1 minus R2, right? 2 times R3 minus R2, right? This means that R2 would be, R1 is written as such 3, 4, 1, 2. R3 is written as such 1, minus 1, minus 1, 1. But now we have this new definition for R2. 2 times R3 minus R2. 2 times R3, 2 times R3 would be 2 times 1, 2 minus R2, 2 minus 2 would be as 0. 2 times R3 minus R2. 2 times R3 is minus 2 minus R2. This is minus 3. 2 times R3 minus R2. 2 times R3 is minus 2 minus R3 minus R2. So this is minus 2 plus 1 is minus 1. Right, and 2 times R3 minus R2 applied on this last row. 2 times R3, 2 minus R2 minus 3 is minus 1. Right, with the result of this operation, this row operation, we have obtained a 0 here, but it is still not a triangular matrix. For that we have to have a 0 here and a 0 here too, right? So this means we have to perform 2 more row operations. Right, so now let's try to have a 0 here that we can implement as R3 is now replaced with R3 times R1 minus 3 times R3. Right, R1, how do you do that? R1, this is R1 minus 3 times R3. 3 times 1 is 3, 3 minus 3 is a 0, so we'll get a 0 here. So we are going to change R3, so we'll write R1 R2 as such 3 4 1 2 0 minus 3 minus 1 minus 1. Right, so R3 is R1 minus 3 R3. R1 is 3 minus 3 times R3. 3 minus 3 is a 0. Right, R1 4 minus 3 times R3. 4 minus 3 times minus 1 minus 3, so it's a 7. Right, then R1 is 1 minus 3 times R3 minus 3. 1 plus 3 is 4. And then we have R1 2 minus 3 times R3. 2 minus 3 is minus 1. So we are left with this matrix. And now we have a 0 here. The last sub-step of step number 2 is to have a 0 here. For that we'll have to keep that 0 as such. Right, so we have to devise a row operation R3 that is equal to R3 plus 7 by 3 times R2. This I have carefully designed so that this 0 remains 0 and this converts to 0. So this is changed to 0. After this operation, this is changed to 0. So let's implement this. Let's implement this operation in this space 3. Since we are changing R3, our R1 and R2 would remain the same. 0, minus 3, minus 1, minus 1, right? So the new R3 is R3 plus 7 by 3 R2. So that would be R3 is 0 plus 7 by 3 times R2. R2 is also 0. So this is 0. So this remains 0, right? Next, for the second column, R3 plus 7 by 3 R2. R3 is 7 plus 7 by 3 times R2. R2 is minus 3. So this 3 cancels with this 3, 7 minus 7. This also comes out to be 0. And then R3 plus 7 by 3 R2. R3 is 4 plus 7 by 3 times R2 is minus 1. So 4 minus 7 by 3. 4 is 12 minus 7, 5 over 3. And finally, this is R3 minus 1 plus 7 by 3 R2. R2 is minus 1. Minus 1 minus 7 by 3. It's minus 3 minus 10 by 3. This is minus 10 over 3. So this is the final triangular matrix in row echelon form, where we have these three elements equal to 0. Which three? These three. This three, this and this. Now we're going to apply step number 3. We're going to convert it to the equation form once again. That would be 3x plus 4y, 3x plus 4y plus c is equal to 2, 0 minus 3y minus c is equal to minus 1, and 5 by 3c is equal to minus 10 by 3. Right, now we have these three equations which we can solve. I want to preserve this original set, therefore I haven't removed it. Right, so with these given equations we can straight away calculate z, because 5 by 3 z is equal to minus 10 by 3. This 3 cancels with this 3, and z comes out to be minus 10 over 5. Z is minus 2. We can plug this value of z here, minus 2, and can find minus 3y minus 2 is minus 1. Minus 3y plus 2 is minus 1. Minus 3y is minus 3, or y is up 1. And finally, we can find the value of x by putting everything in this equation. 3x plus 4 times y, 4 times y, y is a 1, plus c is minus 2, is equal to a 2. So 3x plus 2 is a 2. 3x is a 0, or x is a 0. So with this Gaussian elimination method, we have computed these three values, x, y, and z. Now let's verify whether these values are correct. For that, we have to go through some simple steps. Very simple step. Verification is very simple. What you have to do is to plug these values here in these three equations to see whether these values satisfy these three equations. If they satisfy, your answer is correct. Right, 3x, x is 0, so this is 0, plus 4 times y is 4, plus z is minus 2 should be equal to 4 minus 2, 2, and that is equal to the right hand side. So it is verified. Let's verify the second equation. 2x 0 plus y is 1 minus c is minus 2. So this is 1 plus 2 is equal to 3, and that is also equal to the right hand side of the second equation, this one. And let's verify the third equation. 0 minus 1 minus 2 is minus 1 plus 2 is a 1, and that is equal to the right hand side of the third equation. So our solution has satisfied all three equations. This means it's a correct solution. Right, thank you.